everyone. Welcome to our symposium, The 7 Billionth Human, What Does This Birth Mean? I am Andrew Cherlin, Director of the Johns Hopkins Population Center, which is co-sponsoring this symposium on the occasion of its 40th anniversary, along with our partners, the Bill and Melinda Gates Institute for Population and Reproductive Health. When the Hopkins Population Center began in 1971, the world had about 3.5 billion people in it. Now, 40 years later, that number has doubled. And October 31st, according to UN projections, on that date, the 7 billionth human will be born. What that means, how we think about that as individuals, as nations, as citizens of the world, is a difficult and complex issue. And we're very fortunate to have a distinguished panel of experts to talk with about that issue. The symposium is taking place at the Johns Hopkins Bloomberg School of Public Health in Baltimore, Maryland, USA. It is also being webcast live on the internet. If you are viewing this symposium on the internet, you are welcome to submit questions to the speakers via Twitter using the hashtag #JSHP as in population, H, 7B as in billion, JHSPH7B. And now it's my pleasure to present the Dean of the Johns Hopkins Bloomberg School of Public Health, Michael Clagg, who will introduce our moderator.
Thank you, Andy. I want to thank you and the Associate Director, Emily Agri of the POP Center. I want to thank Amy Choi, who directs the Gates Institute, for organizing this today. It's really not only timely, you've done a great job of getting experts in the field, and everybody in this room is looking forward to it. So thanks for your leadership on this. I want to thank everybody for coming and everybody who's listening on the web. So my happy and pleasurable honor is to introduce Dr. Babatunde Osotomehin, who will chair today's symposium. Dr. Osotomehin was named the 4th Executive Director of the United Nations Population Fund, UNFPA, 2011. Previously, he served as Nigeria's Minister of Health and Director General of the Nigerian National Agency for the Control of AIDS. Dr. Osotomehin did his medical training at the University of Ibadan, Nigeria, and the University of Birmingham in the UK. He later joined the faculty at the University of Ibadan and eventually was named Provost of its College of Medicine. He's a member of the Royal College of Physicians and a Fellow of the Nigerian Academy of Sciences. He also spent 2 years at the Harvard Center for Population and Development Studies. In 2005, he was awarded the Nigerian National Honor Officer of the Order of the Niger. It is indeed an honor to welcome him to the Bloomberg School along with this distinguished panel. Doctor.
Thank you, Dean Clark. Andy, Monsieur. Good afternoon. It gives me great pleasure to be here with you today. And let me thank the Population Center and the Bill and Melinda Gates Institute for Population and Reproductive Health for giving us the opportunity today to have this conversation. Today, we will discuss the 7 billion milestone, and it is what it means to the world. What does 7 billion mean? What are your expectations? What does it mean for women's empowerment? What does it mean for reproductive health and the rights of young people? Rights of the aging population, which will become an issue as we go along. What does it mean for the environment and urbanization? In my opening remarks, I want to highlight some of these issues so that as we go into this, we can carry them along. A while ago, I visited the Horn of Africa. And when I got there, and I saw what was happening there in terms of famine and the affected population, it struck me that we have great challenges across the developing world. The Horn of Africa and what is going on there affects more than 12 million people. It was evident that the crisis goes beyond the issues of food shortages, also goes beyond the issues of reproductive health. There were also issues of violence against women and so many other things which we never actually did think about. Exploitation and various other things. These are not directly related to the issues of population growth, but we have to take them together so we can solve the problems ourselves. And it is the failure of human endeavors that we have actually seen in the Horn of Africa. And that is just an example in one corner of the world. Now, so while shortages occur, we have to ensure that we look at the issues of the environment, issues of water supply, and all of that to go forth. At the same time, our reliance on a healthy, stable, and resourceful environment has never been greater. Until now, food security has merely been an issue of access, but it is increasingly becoming a question of adequate agricultural output. According to the Food and Agricultural Organization, given their 2010 estimates, world agricultural output would need to grow by 70% to feed a population of 9 billion people, with rising levels of consumption and all that goes with it. We are hitting 7 billion this year, and if projections are to go the same way that we expect, by 2045, 2050, which are hit 9 billion. That in terms of food production means that we must actually increase by 70% if we are going to provide adequate nutrition to that 9 billion. Finding ways to achieve this without undermining the ability of future generations for sustainable food production is a massive challenge. But we have to do it. Survival and the instinct to survive is innate in man. And so we need to begin to think about what that means for us. The other side of the population coin is that an expansion of family planning has allowed people to have smaller families, and as people live longer through medical breakthroughs and interventions and better access to health care, the proportion of older people is increasing almost everywhere. As a major global success story, but it also presents societies and communities with new challenges related to economic growth, healthcare, and personal security. We have to begin to think about how we're going to house these burgeoning new people, new old people. 22% of China is going to be over 65 in the next few years. They are going to have to live someplace. They are going to have different nutritional needs. They are going to have different transportational needs. Now that is across the world. And it is not a developing or a developed country situation. It is something that is across the board. And all governments must begin to think about what aging means for their population. Another macro trend that the world is witnessing is rapid urbanization. By 2045, it is predicted that 2 in 3 people will live in urban areas. I recently visited one of the fastest growing cities in the world, Dhaka, which is the capital of Bangladesh. In 1975, it had a population of 2.2 million people. Today, 15 million people live there. And by 2025, it is projected that the city will have to house 21 million people. Now, that really is astounding. I mean, how does a settlement expand like that and has to deal with all the social issues that deal with 21 million people? Overall, the cities of the developing world will double in size in the next generation. The question is how to support populations and make cities livable and sustainable. We reckon that by 2050, 70% of the world will live in cities and in urban areas. Now, those are challenges that we have to deal with. But urbanization can also be seen from another angle. And this brings me to the vast opportunities of the world of 7 billion. While cities have issues of poverty, they also provide the best means of escaping it. Cities have long been the engines of economic growth, and densely populated areas can be more environmentally sustainable than sprawling communities. Urbanization also accelerates the trend towards smaller families and offers more opportunities for women and young children. Women and young people are the 2 population groups with the greatest potential to accelerate progress in the developing world. Investing in women and young people's education, particularly adolescent girls, especially with respect to their reproductive health and gender equality, can speed up economic growth and improve countries' prospects to sustainable development. Educating girls and women and expanding their access to health services, training, and their legal rights towards the economic potential can also result in better communities and, indeed, smaller families. Smaller families can give the countries what we expect should happen, that is, that demographic transition. And if we work with young people today, we have the demographic bonus that can enable it to accelerate progress and growth, productivity, wealth, and economic growth. Currently, almost all developing countries have very large youthful populations. I was saying that I visited Kenya the other day, and I was looking at the census figures of Kenya. 85% of Kenya is below the age of 35. And that implies that is remarkable, 85%. Now, if you go across sub-Saharan Africa, most countries there have the same demographic profile. 70%, a little more, below the age of 35. It's a chance to use this youth, this activity, this energy to do things, but the window is very narrow. They either use them now or they lose it. And if they lose it, it will be a cycle of poverty going forward, because you then continue to have them produce younger people. There are countries where 75% of the girls are married before the age of 15. And that implies that they're going to have children and continue to have children. Now, if that process and if that practice continues, you are never going to get out of poverty. You are never going to get out of the cycle of disease and all. But if we're able to shift, use the energy of young people, educate them, provide for them, let them be part of the economic and political structures of countries, you are going to get that transition. And then, of course, it will affect the growth and the economy of countries. Now, they're a powerful force, so let's use them. I have a simple, maybe too simplistic suggestion. The world is looking to trying to provide an impetus for the green economy because of sustainability. I want to suggest that out of the 7 billion people we are talking about, 1.8 billion of them are young people. If we actually engage the 1.8 billion of them, or of young people, if you provide them with the economic opportunities and the educational facilities to be able to become entrepreneurs of the green economy, what you are going to get is a win-win situation for everybody. They would have a job, they will have prospects, they will see themselves as part of the economic structure. They would also ensure that we have a sustainable planet going forward. And that's something that I firmly believe in, and I think that developing countries should take that forward, because then it ensures that they do not follow the same model of development as the developed world today. And so consumption goes down in those kinds of countries, and you have a situation where you can actually provide a new model and a new kind of way of thinking. Like the Secretary General recently said at the General Assembly, saving our planet, lifting people out of poverty, advancing economic growth, these are the same and one fight. It is not one or the other. My colleagues and I at UNFPA are fully committed to these issues and to ensure access to sexual and reproductive health and rights for all. We are dedicated to improving and empowering the lives of the underserved populations in the world, especially women and young people. The milestone of 7 billion provides an opportunity for us to interrogate what the world means to each and every one of us. And I want to challenge you as you sit here that you should participate in what we have created, the UNFPA, a platform which we call 7 billion actions for 7 billion. So if you go to our website, you will find that we have created this social network to enable you, tell us what you as an individual would do to make the world a better place. And we hope that we'll be able to collect 7 billion actions and aggregate it in such a way to inform human development going forward. I look forward to hearing about the perspectives which others in this symposium will provide. I thank you for listening. Let me now introduce my very good friend, Hania Zornik. Hania Zornik is the Director of the Population Division of the United Nations. And I want to make it very clear, because I think she also would like me to say that the Population Division of the United Nations is not related to United Nations Population Fund. They create the figures, so hold her responsible for the 7 billion. I just talk about what we should do with people. She talks about the figures. Ania.
So thank you very much, both Dr. Osotimein for the introduction. He's totally correct. All the figures he's been citing are our fault. And certainly for Johns Hopkins and the Program on Population and the Gates Institute for the invitation. So what I want to do this morning in the 15 minutes I have is to tell you what it lies behind the figures that are being cited, so that you have a better understanding of why these figures matter and why you should cast doubts on them. Because don't believe, I mean, I'm very happy to go to meetings and to be questioned about things, but everyone thinks that we at the population division know the future. We don't even know the present. At this moment, I'm laughing because some of my dear colleagues in the population field are getting also a lot of press because they say that the United Nations definitely made a mistake about when the 7 billion is going to be reached. And that's why we have a nice tug of war with UNFPA, because we have a date, we gave them the date, but even we do not necessarily believe on that date. We know what problems the data have, and this is an approximate date, and it's likely to vary in the future. We will make another estimate next year, and it's not going to be the same. But what we do believe in is the trends we're analyzing. And let's see here quickly. These are the trends in world population. You may all have heard that we reached the first billion in about 1810, the second billion about 1920, and since then, as you see, the population has been exploding. It is exponential growth, and the growth rate has been increasing and declining lately. Let's see, this is the growth rate, and you see that the growth rate for the same period was very low, almost constant at about 0.5% per year. Then you have an increase, a decline during the First World War and the influenza epidemic, another decline around the time of the 50s that I think, and the Second World War, another decline around the 50s, and I think it's driven by China, and then finally a peak in the late 60s that I think they told me I could make it with the mouse. Yes, here is the peak. This peak is just about 2% per year, a little bit higher. And since then, the growth rate has been declining, not in a smooth way, but it has been declining. And today we have a growth rate of about 1.1% per year. Now, compared to the long historical trend, it's still a huge growth rate. And it still might mean a doubling of the population. Why is it that we're not projecting a doubling of the population is what I'm going to explain next. And we have even doubts that that might not happen. So when I talk about the world, I see the world divided in 3 groups. And it's not the developed, developing, and in between. I look at the groups divided according to the level of fertility they have today. And we have the low fertility group that has, we have defined them as demographers are as countries where the number of children a woman has, the number of daughters a woman has is less than 1. That means a woman is not going to be reproduced in the next generation by the number of daughters. And it's not just the number of daughters, it's the number of daughters who survive to the age of reproduction. The generations are not reproducing themselves. At this moment, 42% of the world population, that's what you see on that table, lives in countries that have below replacement fertility. That means women are not reproducing themselves, and 74 countries account for that group. Then we have the intermediate fertility countries where the number of daughters that survive to reproduction varies between 1 and 1.5. They account for 40% of the world population. There are 65 countries in that group. And lastly, we have the high fertility countries that are only 58. They only account for 18% of the population. They have, every woman has on average at least 1.5 daughters or more. That means the generations are increasing by at least 50%. And it's that group of countries that causes me not to sleep at night if I were not to sleep at night, because they're the ones that are likely to add a lot of people to the world population. Now let's see where they are. The red countries in this map that are mostly in sub-Saharan Africa, but notice that we also have Afghanistan and Pakistan in India, we have Iraq, we have several of the Middle Eastern countries, we have Yemen, we have the Philippines, we have Bolivia, we have several of the Central American countries, Guatemala, Honduras, we have Haiti that you cannot see in that map. They're all countries with high fertility, and several other tiny ones that you may not see. Those are the ones where population is growing very fast. The yellow ones are the intermediate fertility countries, and the thing I want to point out is that the US is an intermediate fertility country because they're hovering around real replacement level. That means 1 daughter per woman. But you also have most of the countries of Latin America, Northern Africa, Southern Africa, and India, very importantly, and several countries in Asia. And lastly, the green ones are the below replacement fertility countries. They include almost all of Europe except Ireland and Iceland here. They include the other developed countries, Canada, Australia, New Zealand, and I think New Zealand is also intermediate. They include, very importantly, many important developing countries. Brazil at this moment, China, several of the East Asian countries. So you see that for every group, it's not just a regional grouping. It's not that all the high fertility countries are in Africa. It's not that all the low fertility countries are in Europe. So it's important for you to bear this in mind, because I'm going to be talking about the difference between those countries, those groups of countries. So in terms of life expectancy, to my surprise, I divided the countries in this group. And what I find is that those groupings are very discriminant in terms of population trends. If you see the lines here, the low fertility countries from the very beginning had much higher life expectancy than everyone else. Again, this bump here is what happened in China during the Cultural Revolution. There's a stagnation of mortality and even a decrease slightly. But from then on, all the time, they have higher life expectancy than the intermediate fertility countries, and these in turn have higher life expectancy than the high fertility countries. So I was not looking at mortality to divide the world, and yet the fertility tells me where they are in terms of other aspects of well-being. The fertility also has been quite different during the whole period. I was just looking at where they stand now, but the high fertility countries were different over the whole period. Ever since the 1950s, they have had relatively higher fertility than the intermediate ones, and the intermediate ones higher fertility than the low fertility ones. So you see that today there are huge differences between the three sets of countries. The low fertility have on average 1.6 children per woman, the intermediate 2.4, and the high almost double at 4.5. They're still very high. And this is after a period of at least, 40 years, because the fertility of the intermediate fertility countries and these ones start really showing a big decline since the 70s. That's why I marked this line here. But with the high fertility, we see a stagnation during a long period, and although there's a decline now, it's a very slow decline. So now I want to show you what our projections have produced. This is the spaghetti, I call it, of all the paths of fertility of all the high fertility countries. And I want to imagine, because I couldn't get a nice graph of this, my colleagues have it, but it didn't have the colors I would like, so I didn't put it in, that the way we project fertility this time is really quite different from what we have done in the past. With colleagues at the University of Washington, my colleagues who do the projections have developed a mathematical model that takes into account, that thinks for us. It's a stochastic model that takes into account the path of fertility decline that each country has had. Then it essentially goes and compares to the path of every other country that has had a fertility decline. From that comparison, it gets a sense of the variation that there is in the fertility change over time. And then essentially, I ask the machine to start throwing dice and projecting the population of the world many times. I mean, of each country, sorry, many times. For each country, the program generates 100,000 possible paths of fertility. And from those 100,000, they take the central path, the median of at each point, and that central path is what you're seeing here, is the one that we use to project countries in what we call the medium variant. At the end, we make only one projection of population from all those 100,000 paths, but we know that that one projection is representing what the statistical model tells us is the central path. And what we found, and we're surprised and happily surprised, is that what the model produces is similar to what we thought ought to be produced, and it's telling us rather interesting stories about what the future may be of fertility for the different sets of countries. Now notice, these are only the high fertility countries. You see in the graph that their fertility in general is very high. I gave you the median, the average value before, that was 4.5 children per woman. But you see in terms of the different spaghettis, there is a constancy, really high numbers. There are some outliers here, like East Timor is one of them, where fertility was low, but after the independence, fertility has shot up. There are strange countries like Yemen that has a huge increase of fertility here and then a slight decline. So the paths are not by all means so nice as constant and then coming down. But from here on, they are pretty nice because they're the ones that we have projected. We start projecting in 2010. And what is interesting to us is that this line that I tried to mark there is the level of fertility that leads you to replacement, the equivalent of one daughter per woman. And we find that most of these countries, in the projections that lead to 9 billion people, have to go or are scheduled to go to below replacement fertility. In order to get to the 9 billion people and 10 by the end of the century, most of the high fertility countries do not only need to reduce their fertility, they have to reduce their fertility enough to get to below replacement level, and rather soon some of them are getting there at 2030, 2045. There are a few that don't make it, and the population growth of these countries is staggering. But even at the end of the century, they're having very low fertility compared to where they start. So the challenge that we pose to our colleagues at UNFPA and everyone else that is working on development is, what do they need to do to make these projections come true? Because we're not sure that they will come true. That's what the numbers tell you, if the past gives you some idea about what the future is going to be. Now let's look at the intermediate fertility countries. You will see immediately that here is where the decline of fertility has already happened. You see that they're very low already. Many of them are already reaching levels that are below the 2.1, although they shouldn't, because I selected them as not. So my graphs are not that perfect in terms of what you see. The line is I cannot draw the line perfectly. But from there on, almost everyone is going to be below replacement fertility very soon, according to these projections. And by the end of the period, definitely everyone is below replacement fertility. So again, that is it's necessary for that to happen, to slow population growth enough to get to 9 billion and 10 billion and nowhere, and not any higher. And lastly, we have the low fertility countries where the story is different. They're already clearly below my red line. And you don't see it very clearly, but for all of them, the projections mostly make the fertility go up very slightly, very slowly, but instead of keeping at a fertility that is average of 1.6 as it is today, they go to around 1.9 or 2 later in the century. So again, I have problems telling the story of why our projections come out this way, because there are different outcomes for different types of countries. The high fertility, the intermediate fertility countries still reduce their fertility. The low fertility countries have a slight increase of the fertility. Because they remain below replacement level during the whole period, nevertheless, their population is going to decline. Okay, so now let's see what this produces at the world level. When we aggregate all the numbers, the fertility that we have projected, it starts at 2.4 children per woman at the world level today. And in the medium variant, we projected to go to 2.03 children per woman in 2100. Now, this is the median projection that comes from the probabilistic 100,000 paths per country. But in order to give some sense of the sensitivity of the projections to fertility, we don't use the probabilistic approach. What we're using is just a plain old recipe method. And the recipe is we make every country have a high variant that is just half a child above the medium, and a low variant that is just half a child below the medium. And at the world level, it produces a total fertility in 2100 of 2.51 in the high and 1.55 children per woman in the low. And those two variants are going to give you a range of variation that depends on a very small variation of fertility, just half a child above and half a child below, something that is close to replacement level, which is the median variant. Let me see. Now I'm going to show you for the different sets of countries how these variants look in terms of fertility. Here we have the high fertility for the high fertility countries. They go to 2.6 children per woman at the end of the century. The median variant goes to about 2.1, and the low variant goes to 1.6 children per woman. But I've added two other variants that are very interesting, that we think are they're not going to happen, but that they are going to give you insights about how the population may or may not grow in the future. This one that we call no change is where we keep every country at the fertility and mortality level that they have today, and we project it constantly. Now, the first thing that I want demographers to notice is that on average, these countries have 4.9 children per woman at the time we start the projections, which was 2005, 2010. And even though we keep every country with a constant fertility and mortality, you see that the fertility of the group increases. And why is that? Because there is a reconfiguration of the weight of the population. The countries that have the higher fertility are going to get more people, and therefore they have higher weight. So the fertility of the group increases instead of declining. That's why we don't think this will happen, but if not much is done, it's possible that there might be stagnation and things remain similar to that. Then we have another variant that is what we call the instant replacement variant, and that's where we make every country go immediately in the first period to exactly having one daughter per woman. And you see that the fertility drops very drastically, and then it more or less remains constant. That's the instant fertility. Now, quickly, I'll show you the similar graphs for the intermediate fertility countries. And the point to note here is that the constant, the no change, is slightly higher than the high, but not that high, as it was in the other one. The instant replacement is similar to the median, because these countries are so close already to replacement level that it doesn't make much difference. For the low fertility country, the instant replacement is the one that gives us the highest fertility, because they're so low that to go to instant replacement is to make them grow when they're ready to decline. And the no change gets us to close to the low, because they're already so low that they're going to get to lower levels. So again, there's a different story to tell about each group of countries. I'll skip that one. Oh, okay. Sorry. So now, these are the results we get. At the world level, I've decided to put it like this, because I want you to focus on the numbers. This is the place where we start. We start the projections in 2010, and we had then 6.9 billion. Not the 7. The 7 is a little projection to 2011. But to 2050, this is the array of numbers we get for the world. The one in pink is the median variance, so that's the 9.3 billion that everyone cites. 8.1 and 10.6 are the low and the high variant. You remember, they differ only by half a child, and yet in 2050, that's giving me a difference in 2.5 billion people, the equivalent of the population on Earth in 1950. So it's not a small difference, but it might not be too shocking. It's, 1 billion more here, 1 billion less there. Constant, this is the instant replacement. That's what's interesting. The instant replacement, which is the one that takes every country to the place where they get to stability, and the best stability that demographers know, every generation reproduces itself, it gives us also 9 billion. So some of my colleagues, especially writing statements for Mr. Osotimein, make the point that there is so much accumulated momentum in the age structure of the population, so many young people already, that even reducing fertility to the stable level, you still are going to get this growth of at least 2 billion more to get to 9. And then you put the constant, the no change variant, and we get to 10 billion. It doesn't seem to be too different, okay? In fact, the high variant gives you more than the 10 billion to 2050. But that's the reason why we decided to exaggerate the trends and go to 2100. Because these numbers, although they're similar, they're not equivalent. By taking the different paths in fertility, countries are setting themselves up by creating momentum for the future that they cannot stop. And you see it better if you let the clock run longer and see what transpires. And to me, these are the most interesting numbers, although they are not really very necessarily realistic projections, because we're going so far out. The medium, again, by making every country go to below replacement level almost towards the end of the century, we only increase the population to 10 billion. And after that, most countries are below replacement level, so their population eventually will start declining. But if we go to half a child less, they will decline faster. They will already be declining by the end of the century. So instead of growing to 10 billion, we could decline to 6 billion. If we have half a child more, we could increase to 16 billion. The difference now is 10 billion. That makes your eyes open. It's not the 2.5 that we had here, but it's the continuation of the same paths. Instant replacement, because it was taking us to the stable thing, takes us again to something like 10 billion. That makes us believe that the path to 10 billion is the best we're going to be able to do. But no change takes us to 18 billion. And again, Dr. Osotimain mentioned very appropriately the challenges the world is facing today. The challenges of feeding people, the challenges of producing enough food for all of us that consume so much and the other ones that don't have enough to eat, the challenges of where we're going to live. Are we going to all congregate on the small cities and live on high skyscrapers with very little room? All that is going to be exacerbated if we get to 18 billion people, when already the FAO, the experts on feeding, are wondering whether we can feed the 9 billion that we expect by the middle of the century. So if there's a challenge to feed 9 billion, I can assure you that I don't think it's going to be very easy to do the 18. So I don't think that constant trends as we have them today are going to be viable. Even if we go not to our median projection that takes every country to below replacement fertility, but that goes like 2.5, 2.3 children per woman, we have problems because we're still going to double the population of today. So that's the message. We need to continue to slow down population growth. And as I tell everyone, and everyone knows it, there are two ways of reducing population growth. There may be a third one, but I don't think I can entertain it. The two is more people die, or they die sooner, or the other one is you reduce the number of children we're all having. Since we don't want people to die more, these projections all assume that the expectation of life of every country is improving, then we need to reduce fertility. That means fertility has to come down. So I'll just briefly present to you that most of the growth that appeared in the world is coming very much from the growth of the high fertility countries. This graph at 2050, again, you don't see a big difference. You know, they start with 1.2 million people. They're going to more than double by 2050 in the medium variant, but if not, the low and the high produce 2.3 and 3 billion, again, a very small difference. Instant replacement would take them to 1.8, and no change would take them to 3.3. But if we keep on going till the end of the century, no change takes them to 11 billion. That's where we get that 10 billion. These are the countries that deserve our attention more than anyone else. Because I'm running out of time, I'll skip the others. And I'll give you just some hint of something interesting that we're doing. These projections that we did, as I tell you, I decide what's the interval, the half a child above and half a child below. And they produce these paths of population. In this case, we have Nigeria. It's just one country. And they produce, for Nigeria to 2100, an interval where the possible range of population may be between 500 million people and 1 billion, with a median variant of 0.73 billion, that means 730 million people. But these are projections that we decided how they were created. If we run the statistical machine and we get the real probabilistic intervals of where the population will be, we find that in these high fertility countries, our plus 5 minus 5 projections are too narrow, that the intervals that are almost sure to contain the future population are a lot wider. And the future population could be anywhere from between 350 million people to 1.37 billion people. And this is telling us that there's a great uncertainty in the future of the population of high fertility countries. Now let me compare them with an intermediate fertility country, India. India, here are our -5, +5 projections, and you see that they almost match the 95% confidence intervals. Because fertility has come down so much already, the program figures out that the confidence intervals are not, that the change in fertility is likely to be within the plus half a child, minus half a child range. So we are likely to be doing slightly better in projecting the population of India than in the population of the high fertility countries where there's a lot more uncertainty. The next one is the low fertility countries. China is the poster child. We have the -5, +5, and look, the +5 is the one that looks very strange. When countries have fertility that is already so low, the statistical machinery is telling us that it doesn't think that it's very likely that they'll follow this path. It's more likely that they'll follow a much narrower path that is between these two ranges. That still gives us a big range in the population, but it's consistent with fertility that is a much narrower range than what we have in the other one. So the big message is, I do not know what the population of the world is going to be in 2050. I do not know that 70% are going to live in urban areas. We are paid to give you numbers, we give them to you. We're also very concerned about letting you know what we assume in order to get to those numbers. And our assumptions, especially about population growth in the future, demand that fertility comes down much more than it has done in most of the countries of the world, but especially in the 58 that still are having very high fertility, and that happen to coincide with countries that are already very poor and that have other socio-economic issues from which their population is not being able to escape, and therefore the population are not having the best possible lives they can have. That's why what Dr. Osotimein said at the beginning, the fact that the United Nations has put a lot of emphasis on improving the lives of these people is still a high priority. I'll remind you that this is the high and low projections for the whole world, the ones that everyone cites, and that give you already a 10 billion difference between the low population and the high population in 2100. Lots of uncertainty, even though these are not the probabilistic projections. And my two coda parts of the presentation is that this is a graph of contraceptive prevalence of all the countries for which we had data, and where we graph in red the ones that have low fertility, in yellow the ones that have intermediate fertility, these are the ones, and in green the ones that have high fertility. You see there's overlap and a lot of variation, but in general you can say that the ones that have low fertility and intermediate have very high contraceptive prevalence, and the ones with high fertility are having very low contraceptive prevalence. So that means, to me, it continues to be essential to make sure that women have access to effective contraceptives. And to complete is to show you that since 1996, and when UNFPA started measuring this, it's not my data, it's UNFPA. Since 1996, the funding on family planning given by donors, not the national funding, because the data on national funding is more difficult to get to, but the donor funding for family planning on a per capita basis, per woman of reproductive age, whose numbers has been growing, has declined by at least 50% in most of the countries in yellow. So you see, in most of the countries, especially the high fertility countries, others also, the donor funding directed to family planning has not kept up with the needs. So I submit to you that although I don't have absolute proof, this is part of the reason that some of these poorer countries have not managed to achieve the declines of fertility that the better off countries have managed, because they have had higher resources to spend in their population and improve their lives, not only via family planning, but other interventions that are critical: reduction of child mortality, improvement of education. But without family planning, even those things are not necessarily going to lead to people actually having the number of children they want. One of my friends in many of the meetings I've gone to said something very important, that as far as he knows, even very educated women like I cannot produce contraceptives in our kitchens. So if we need the contraceptives, we need the services. Okay, thank you very much.
Thank you very much, Annie. And as you see, she has pushed all the responsibility to us. But I think that given the fact that the population division produces those projections and figures, you have to now join the dots. It goes beyond the fact of figures. It is about the completeness of life, the lives of women, the empowerment of women, access to education, access to information, the rights of women, and the rights of young women to be able to make choices and ensure they have access to reproductive health, especially family planning. I think that's what's going to make the difference going forward. Now, the one thing, of course, which we haven't talked about a lot, but which is also important going forward, looking at planet Earth and ensuring that we have a better world to live in, is about climate change. And I think we couldn't have had a better person to speak to us than Brian O'Neill, who is one of the most distinguished people in this area in the United States, and is of the U.S. National Center for Atmospheric Research, and is one of the leading young climate scientists. He will discuss his latest estimates of the contribution that lower population growth could make to reducing carbon emissions. Brian.
Well, thanks very much for that nice introduction, and thanks also to Andy and the Gates Institute and the School of Public Health in general for inviting me here. It's a real honor to participate. I'm going to be talking about the implications of the projections of population growth that Hanya just talked about for one environmental issue, for climate change. Now, I hope that it goes without saying that there are lots of implications of additional people coming into the world for families, for communities, for economies that have nothing to do with the environment and nothing to do with climate change. And my goal is not to argue that consequences for climate change are the most important kind of consequence of new people coming into the world. Rather, my goal is to talk about what do we actually know about what those consequences are. And that's important because this has been a topic that there's been some confusion about, some controversy. Some people view population and population growth as the fundamental driver, not just of climate change, but of environmental problems in general. Other people view population as unimportant to environmental outcomes, and worse than unimportant, actually a distraction from the real issues. So where does the truth lie in between those two extremes? To get at this question, I would like to share with you some of the results of work that we've been doing over the past few years. And by we, I include the people who are up here on the screen along with me, that include economists from the National Oceanographic and Atmospheric Administration, other colleagues at NCAR, and also colleagues at EASA, which is an international research center in Austria. And this work looks at what the consequences, potential implications of demographic change could be for future energy use and emissions that drive climate change. So the first caveat is that I am leaving out half the story. Demographic change is also going to matter not just to driving climate change through energy and emissions, but also to what the consequences of that climate change actually is for society. So how many people there are, how fast the population is growing, how old or young or rich or poor or well or poorly educated we are, and where people decide to live in the future. All of those things are going to be important factors in figuring out how important the consequences of climate change for society might be. And I'm not skipping them then because they're unimportant, but simply because we've done more work on the emissions side than on the impact side. So for starters, what is climate change? And this is not going to be a science talk, but let's just take a minute to make sure we're all on the same page about just the very basics that we need to know to understand the emissions work. So climate change is caused primarily by the buildup of greenhouse gases in the atmosphere. The most important greenhouse gas is CO2, or carbon dioxide. And carbon dioxide is generated in primarily two ways. One is deforestation. Cut down trees, burn them, that puts CO2 into the atmosphere. The other and more important source is burning fossil fuels for the production of energy. Fossil fuels include coal, oil, and natural gas. And we use these, of course, fuels to generate energy to power factories, bring electricity to our home, heat and cool home with natural gas, and so on. So our project is on looking at the role of population in driving that energy use and those emissions. Now, in general, population is pretty widely recognized as one of the factors that is important to determining how much energy we use and what the emissions are as a result. So why are we looking at this if everyone knows that population is a factor already? And as I said, it's because there's been disagreement over how important it is. How big of a deal is population? Is that a big driver, a small driver? Does it matter? Does it not matter? And there have been some estimates of this done already, but they've been fairly simple and fairly preliminary. And they've left out a couple of things that have allowed there to be actually a lot of disagreement over what the conclusions are. And a couple of those things are, one is interactions. So having a model or a projection that has population size in it allows you to say, okay, I can calculate the fact that if population is smaller, we don't need as much energy simply because there are fewer people around. But maybe that slower growth in population has indirect effects, for example, on the economy. It may allow the economy to grow faster, which would offset some of that reduction due to having fewer people around. Maybe offset it completely. Maybe there would be no net effect. The other kind of factor that's frequently been left out besides interactions is other demographic changes beyond changes in population size. And we know that along with changes in population size and different growth rates, we will also see differences in aging and in urbanization and even in living arrangements, numbers of people on average per household, for example. And we know from other research that all of these factors can also influence energy use and emissions. So maybe by leaving them out of most of the analyses so far, we're really missing part of the story. So our goal was to address some of these shortcomings in previous analyses. And we did that fairly simple idea for a design for the study. Number one was to take an energy model, an emissions model of the kind that are typically used to do long-term energy and emissions projections in the climate change research area and modify it to do a better job of handling demographic change. Second, to take some long-term alternative population projections, and we relied for the most part on the products from the UN of the kind that Hania just described, and then put the two together and say, well, what do these alternative demographic futures imply for emissions? How much difference does it make to emissions if the population grows faster or slower? So let me just say a little bit about each of these and ending with the conclusions on how the emission scenarios turn out. I won't go into any detail really on the kind of model that we used. Here's a little cartoon version of it on the right. The type of economic energy and emissions model we're using in economics is called a computable general equilibrium model, or CGE model. For our purposes, we just need to know that what it's basically doing is dividing the world up into a bunch of regions, and then within each region simulating decisions that households make about how much to consume, how much to save, what type of goods to consume. On the producer side, simulating decisions that industries make about how much to produce and how to produce it, how much labor to use versus capital versus, for example, energy as an input. And importantly, some of those industries are energy industries. And so the use of energy in the economy to produce goods that households consume, depending on whether that energy is fossil fuel based or renewables or nuclear, is what produces CO2 emissions. So the model is a complete accounting for energy use in the economy. It's not just energy that's directly used by households to turn your lights on or heat your home, but it's also the energy used by industries that built the house, produced the furniture, manufactured the clothes, and so on. And for our purposes, a couple important things in the way the model works and some of the modifications we made are what kind of effects demography has. So in this model, there is an effect of population growth on economic growth. It's relatively weak, consistent with the literature on this topic. If the economy grows a little bit, if the population grows a little bit faster, the economy grows a little bit slower, and vice versa. There is also an effect of compositional change in the population, of change in the age structure or urbanization on economic growth that we'll come back to in a minute. And finally, changes in the types of people, not numbers, but how old they are and whether they're urban, rural, also affect consumption patterns. And because different types of goods require different amounts of energy to produce them, that also can affect emissions. So let me give you an idea of a little bit of the data that goes into it, and also an idea of what are actually the relations between different household types and their effects on the economy. And as I mentioned, there's two, one on the production side, on economic growth, and another on consumption patterns. So on the production side, one key determinant or driver of economic growth is the productivity of labor, of workers in the economy. And typically in these kinds of models, labor productivity is measured using current data on labor income per capita. And we follow this approach, and here's data that we're using for our China region that shows in our initial year, and here that's 2003 for China. This is data on labor income per capita that is divided between urban and rural households, and also differentiated along the x-axis here, which is the age of the household head, as reported in the household survey here. So you see that labor income varies over age, and it also varies even more sharply between urban and rural. So this implies here that urban labor, urban workers, are more productive than rural workers. Now that's not, we should keep in mind because they're harder workers or better people or anything like that, but it's, you can think of this as the contribution that labor makes to GDP growth. It's a way to understand productivity. And so if China is urbanizing over time in the future, we're moving people from the red rural line to the yellow urban line, and we would want to take that into account in how fast this may cause the economy to grow, therefore how much energy gets used and emissions. Now, let me give you one example on the consumption side. This is data from India that divides households in India into three groups: rural on the left, urban in the middle, all urban households, and then households that are really in the city centers on the right. Now, I'm not showing consumption of all types of goods by the household, but here just the direct energy goods that are consumed by the household. The main message here is that they're different, that if you're in an urban household, you consume different types of goods than if you're in a rural household. Here, the major difference is that if you're rural, most of your energy is coming from traditional biomass. As you move towards city centers, your energy goods become dominated by more modern fuels, particularly electricity and gas. And again, we are anticipating lots more people being in the urban category than in the rural category over time. This will have consequences for consumption choices, the types of goods being consumed. Now, not only for the energy goods that I'm showing here, but actually for all goods, for food and other types of goods that people are consuming. And we want to be able to account for that. So in this model, these sorts of data are used to calibrate preferences that households have for consuming different types of goods. As I mentioned, the model divides the world for us into 9 regions. So there are these regional economies of the kind I described interacting within each of these 9 regions, also interacting between regions through trade. 3 of those regions are individual countries, the US, China, and India. Other regions are large aggregates of many countries together. And in each of these regions, we're using the sort of household survey data that I showed to calibrate the behavior of households, except for sub-Saharan Africa, because we've only recently gotten some data that we could use to calibrate households there. Okay, so that's how the model works. The population inputs we're using are very similar to the population projections that Hania just showed. These are projections from the UN. I'm showing the global projections here. They're not actually this most recent version that Hania showed. They're from the last iteration. So the numbers are a little different, but the differences between the scenarios are relatively similar. So population is growing from 6 or 7 billion in the start of the century to around 9 in this projection at the end, but in a high scenario could go as high as 14, in a low scenario below 6 by the end of the century. As Hania said, where that growth is coming from is concentrated in the highest fertility countries. These colored bands show, kind of decompose the difference in the global population totals into where is that difference coming from. The only thing I want to point out here is, as Hania emphasized, so the purple and beige colored bands here are for the developing country regions in our model. The green ones at the top are the industrialized country regions. So most, nearly all, most of the difference between a medium and a low or a medium and a high projection for the world is coming from developing country regions. So we use these projections. We combine them with urbanization projections. We also are using the age structure that lies behind these projections, and we also convert them into household living arrangements in each country. So there's a lot of demography here that I'm going to skip over, and we're using those then to drive the model and see what difference do these 3 alternative population paths make to emissions outcomes. So look at the results. We'll start with the most aggregate result here, which is total global carbon emissions in each of these 3 scenarios. The blue one is a scenario that we're calling B2 medium. Medium means medium population growth. B2 is kind of a shorthand for all the other assumptions that you have to make to generate a long-term scenario about increases in productivity, technological change in various industries, and so on. And this B2 is sort of a medium, middle-of-the-road, business-as-usual scenario. I wouldn't worry too much about the up and down kinks. Those come from details of the assumptions about what's happening in the energy system. But you see, under the medium scenario, global emissions start off around 6 or 7 billion tons of carbon per year, and they nearly double by the end of the century. In contrast, if we run the same scenario but have high population growth, we end up, by the end of the century, nearly tripling emissions. If, on the other hand, we have low population growth, emissions are, by the end of the year, or end of the century, back down around where we started. So is this a large effect? That's really the question. And I think it's clear in the long run it's a large effect. It's kind of hard to conclude that it's not. Just taking the difference between the medium and the high, that population difference leads to a difference in 7 billion tons of carbon, which is about total emissions today. In 2050, over a time scale that's a little more tangible, it is a little less clear. So we find between the medium and the high scenario, 10 billion tons versus 11.5 or so. So a difference of about 1.5 billion tons of carbon due to following a different population path. So that's 15 to 20%. How big of a difference is that? Well, one way to measure it is that the current policy discussion of emissions limitations aimed at keeping global warming to below 2 degrees. Translating that into emissions, that is aiming to have emissions in 2050 down here at the bottom of the graph around 4. Right? So if you're up around 10 and you need to get to 4, and 1.5 billion tons of carbon you could get that amount of carbon difference from the population path. Is that a lot or is that a little? I mean, I would say certainly it shows that you are not going to solve the climate problem by following a different population path. On the other hand, getting from 10 to 4 is pretty tough, and probably every billion tons really matters. So 1.5, is a contribution. The last kind of result I will show is, so how much does this aging and urbanization matter, for example? All of those results I showed you were the net result of all of the demographic changes taking place at the same time. This plot is about, let's just take the medium scenario. We're not comparing two different scenarios, but in the medium scenario, how much difference is aging making to the emissions outcome, and how much difference is urbanization making? So the blue bars show globally that the light blue one is in 2050. In 2050, aging is pushing emissions down by about 500 million tons per year. By the end of the century, it's up to 1 billion tons. Urbanization is pushing it up by half to closer to 1 billion tons per year by 2050, and more than that by the end of the century. This is primarily due, remember, there's two effects that aging and urbanization can have on labor productivity and economic growth, or on consumption patterns. This is mostly due to the economic growth effect. So aging, you get people where their labor productivity falls off as they're more in retirement ages, the economy grows more slowly. Urbanization, as we saw, urban population has higher labor productivity, economies grow faster, pushes emissions up. Does this matter, 500 million tons, 1 billion tons? Well, one way to look at that is to say, well, globally, we started off at 6 or 7 billion tons. By 2050, we increased 3 or 4 billion tons. Global emissions went up 3 or 4 billion tons. Urbanization was about 1 billion of those tons, was due to an increase in emissions due to urbanization of 1 out of, say, those 4 billion tons of increase. So that, I think, is actually a significant component of drivers of increased emission growth, and aging working in the opposite direction. So obviously, as you can imagine, these things have different importance in different regions. Urbanization is mostly acting through, for example, in Asia, China, and India. The green bars are very large here. It's the same plot, but by region. Aging is happening in China as well. Everything is happening in China. I think we all know that by now. It is a very dynamic region. And also in industrialized country regions. So these happen, urbanization is not important everywhere. Aging is not important everywhere, but in some places. So to conclude, I think, this study, we have not included all potentially important interactions between demography and the economy. I think we've taken a reasonable step forward in doing a much better job than has been done before. And so far, the net effect of population growth is to increase energy use and emissions. And we got a little bit of sense of by how much and how big of a deal is that. Urbanization and aging do strongly affect emissions in particular parts of the world. Not everywhere, but in some places, it's really important to take those into account in thinking about the consequences of climate change. Of course, in the end, an important question is what this means for policy considerations. And again, this talk is not about advocating a particular policy approach to climate change or to population. I hope that this kind of work can inform such a debate, in that I think that as far as we know now, based on this evidence but other evidence as well, that slower population growth would probably on balance reduce emissions. Not enough to solve the climate problem, but it could make a contribution. Now, whether that means that one should support such policies is another matter entirely, because there's many things that go into deciding whether a particular policy approach is good or bad above and beyond its potential effectiveness. But you'd want to know about its effectiveness at least to begin with, and that's what this kind of work was aimed at. Thanks.
Thank you, Brian, for provoking thought, and I'm sure that the audience will have many questions and clarifications to ask him. Our last speaker today is actually, you leave the best to the last, and I think that's what we are getting. David Lamb is a professor of economics at the University of Michigan. He is currently the president of the Population Association of America. He's a demographer. and he's done quite a sizable amount of work in areas of demography, and has an economic perspective in current and future population growth. David Lam.
Great. Thank you very much. Well, it's a real pleasure to be here, as others have said, and thanks very much for the opportunity. And I'm definitely not sure about the best to last, but maybe you'll find it the most optimistic to last, at least. So we were asked to speak on the meaning of the 7 billionth child, and it's a significant milestone. I think it's a very appropriate that that Hanya's group, the UN Population Division, has picked a day. I mean, we know it's a little bit of a arbitrary day, perhaps, but I think it's a good exercise to focus the mind. And interesting that they picked Halloween. And I think, especially given the previous talks, I think some people think it's very appropriate because they're all finding all this a little scary. So the 7 billion sounds kind of scary. The getting to 10 billion by 2083 and 10.1 billion by 2100 sounds even scarier. So I've decided to organize my comments around the question of should we be afraid or should we celebrate? So those are going to be my theme. And Hanya and Brian did a very nice job of looking forward. I'm actually going to look back, and I'm going to argue that this is not as scary as it sounds. And I think one way to think about that is to go back and imagine that we're gathering here. This room probably wasn't here in 1960, much too nice a room for that. But suppose we were having the same event for the 3 billionth human back in 1960 when the 3 billionth human arrived. And how would things have looked then if we'd been looking forward? So imagine we're looking forward, and I'm going to be going over some ground that I covered in my Population Association presidential address. So those of you who heard it won't be too surprised where I'm going. But I think it's very important to look back if we're going to think about what lies ahead, and think what can we learn from looking back at what I would argue is the most extraordinary period of demographic history that the world not only has ever seen, but ever will see. So not only did the world hit 3 billion in 1960, but as Hanya's graph showed, the world population growth reached 2% per year, exceeded 2% per year, almost surely for the first time ever in human history. And as you could see from her graph, and I'll show it again in a second, a version of it, arguably will never happen again. We hit 2% per year. 2% per year implies a doubling in 35 years, and that's about what happened. We grew from 1960 and 3 billion to 1999 and 6 billion. So we're thinking about this, what's going to happen if we get to, even to 12 billion? Well, imagine, in 1960 saying, we may double in population in 39 years. None of these scenarios, even Hanya's most extreme scenario, didn't have us doubling in 39 years. So suppose we're going to double in population in 39 years. What would that be like? How unusual was that? Well, the previous doubling was about 70 years, 150 years before that, probably about 500 years before that, maybe 1,200 years before that. 39 years was absolutely unprecedented, and if we did the guessing game, those of you who attended the PAA address know I posed the question, what's the next number in this sequence? What's the next doubling time? And Hanya's basically shown you the answer, which is that my guess would be the next doubling time is never. The world will never, ever get to 12 billion. But if we do get to 12 billion, even in Hanya's some of the more extreme scenarios, it's for sure a good deal more than 39 years. So the world will never again double in 39 years or anything close to it, and indeed may never double, period, which is kind of an amazing thought. And I don't have time to go into all the details of why that is, but you can sort of see from Hanya's analysis. So this was just her data, again, the 2100 projections from their most recent scenarios. There we are going from 3 to 4 to 5 to 6 to 7 very rapidly, kind of 14 years, 13 years, 12 years, another 12 years. The next one's actually also about 12 or 13 years, if you believe their projections. There's the medium and the high and the low variant, as was discussed. But none of those actually have getting to 12 billion in anything like the 39 years. So what's the point? Well, the point is that we've been through the most rapid population growth that the world will ever see, I would argue. That's not really a bold statement at all. That's, you know, almost surely the case, and even under some of these high scenarios. So it's a good time to look back and think what happened. Just to remind you what the growth rates look like. Hanya also put these up, they sort of look like this. So up in this period here, we got to 2% growth. We were only there for about 10 years. We're still living with the consequences on that, in that we have a lot of population inertia. The reason we're still at 1% here, even though you know, most of the world is living at around replacement fertility now, as Hanya showed, is because of population momentum. There's a lot of women of childbearing age. So current fertility rates already imply considerably lower growth than that. And so there we go. And so, as I said, I really want to look back at what happened. Okay, so if we're thinking about, you know, another way to pose the question is this 7 billionth child, you know, what is life going to be like for this 7 billionth child? Is it going to be better or worse than the 3 billionth, 4 billionth, 5 billionth, 6 billion? Well, I would argue it's going to be better. I'm going to look at several dimensions: food availability, poverty, education, resources. So on food availability, I can't talk about projections in the 1960s without bringing up Paul Ehrlich, whose 1968 population bomb made some, certainly not the only book of its kind, but certainly the best known, making projections about what would happen in the future. And it's a fairly gloomy story. Population control or a race to oblivion. Here's a projection in particular about food. And food has come up several times, and you know, we may need 70% more food. That seems like a staggering amount of additional food to produce. And if we were looking at it in the 1960s, this seemed particularly scary, and Ehrlich and many others predicted the developing world is running out of food, the battle to feed humanity is already lost, we will not be able to prevent large-scale famines in the next decade. Well, what actually happened, this is world food production from 1961 to 2009 from the UN Food and Agriculture Organization's data. We produce 3.1 times more food today than we did in 1961. Okay? So food production has more than tripled, so that makes going up 70% not seem quite so scary. Population has more than doubled, as we've seen. It's up 2.2 times. So per capita food production is 41% higher today than it was in 1961, which is when these series begin. Okay, so we have 41% more food, in spite of the fact that we grew at this absolutely unprecedented population growth rate. Now that's the world. We were even more worried about particular countries, like India. India was a country that Paul Ehrlich made some predictions about running out of food. Many other people did as well. Ehrlich quoted agricultural economist Louis Bean as saying that India was producing basically as much food as it would ever be able to produce in 1968. And India is a good choice for the discussion today because India is probably a good candidate. If we said to guess where the 7 billionth child will be born, India is probably the maximum likelihood estimate. Later on, more predictions from Paul Ehrlich and Ann Ehrlich in a sequel called The Population Explosion. The country appears to be facing a catastrophic problem in the 1990s. Well, here's food production in India. This is actually, these data go up to 2009. Food production in 2009 in India was 3.6 times higher than in 1960. Even higher, bigger increase than for the world as a whole. Population went up faster than the world as a whole, 2.6 times. India was growing faster than the world on average. So per capita food production today in India is 37% higher than it was in 1960. So the point, this is, we sort of did an experiment here that in some ways was, turning things up completely out of control, more than doubling population in a 40-year period in India, 2.6 times in a 50-year period, and yet there's 37% more food per person at the end than there was at the beginning. If we looked at some other countries, the numbers for Brazil, for example, is producing 8 times as much food today as it was in 1960, or almost tripling of per capita food production. Now, not everybody has done that great. Sub-Saharan Africa is a case and has come up. Sub-Saharan Africa, actually, food production is 3.3 higher. That's also higher than the world as a whole, and many of you might find that surprising. So food production in Sub-Saharan Africa is over triple what it was in 1960. The problem is that the population is even more than that. So this is, where the things to get nervous about come in with these rapidly growing countries in Africa. And per capita food production has actually fallen a bit from its 1960 levels, about 7%, although we see that it's been rising here since about the 1980s. So there are some positive glimmers there in the African data. It's not all bad by any means. Okay, so there's many things that we could look at, sort of how have things gone over time. Another is to look at poverty. If we look at poverty estimates, is this 7 billionth child more likely to be in poverty than the 3 billionth child? Well, almost surely lower probability of being in poverty. These are the estimates the World Bank has made of poverty at their $1.25 per day poverty line. Poverty has basically been cut in half from 1981, which is when their estimates go back to 2005, from about 50% to 25%. At the $2 a day, it's from 70 to 47. China is a huge part of this. China has had a massive decline in poverty, so it's not quite as impressive if you look at the world, developing world outside of China, but it's still a decline from 40% to 29%. And if you look at particular regions, there's East Asia. That's really about China. Huge decline in poverty in China. Imagine making that prediction in 1960, that poverty would be falling from 80% to 17% over that period of time. Latin America had lower poverty, hasn't changed much. South Asia, this is mostly India, a decline from 60% to 40%. And Sub-Saharan Africa, again, the kind of laggard in these things. But even in Sub-Saharan Africa, actually a decline in poverty somewhat in the last decade or so. So that's poverty. We could look at many other measures like infant mortality has improved. An Indian child today has about twice the probability of surviving the first year of life as in 1960. Many other positive measures. I just want to show education. This is education in Brazil. This is the percentage of a cohort with primary schooling. It's increased from 20% to 64% for males. It's increased even faster for girls, and the gender gap has been eliminated. We see this all over the world. And especially amazing when we consider that school-age populations grew, sort of off the charts in this period. School-age populations will never grow as fast as they grew in this period, and yet it was the period of the fastest improvements in education, surely, that the world will ever see. There's just Thailand, which is even more impressive, a huge increase in schooling, and also a closing of the gender gap. Okay, what about resources? Resources is another thing we worried about a lot, running out of resources. And I'm going to show some data on resource prices. I can't see that. Okay. So I'm just about to finish up. So resource prices, I want to mention Julian Simon. I brought this up at the presidential address. And I want to bring up Julian Simon because I want to mention his famous bet with Paul Ehrlich about what would happen to resource prices. So Simon wrote this book, Ultimate Resource, with this crazy quote: "Every trend in material welfare has been improving and promises to do so indefinitely." So super optimistic view of the world. And he, in the book, had this offer to bet anybody that prices of any resource you could name would go down in the future. And many of you may know this story, but quickly they picked 5 metals, Paul Ehrlich and his team at Stanford, They bought $200 of each in a kind of a hypothetical futures contract, and the prices of them all went down over the next 10 years. So what you could buy for $1,000 in 1980, you could buy for $618 in 1990. So big declines in prices, interesting stories behind all of them, but basically Simon was right about the prices going down. This is those prices over the whole period of time, and it's a little more complicated. You can see actually Simon was kind of lucky here. He picked a period where they really did go down. They'd been going up, although they actually kept going down. If the bet had gone to 2000, he would have won even more. But then since then, we've had this big increase. And that, I'm going to come back to that in my final little bit here. That's resources. What about food? Now, many of you have probably heard about the stories that we're having the highest food prices in history. And I keep seeing stories like that, and they're based on this index here from the Food and Agricultural Organization, which begins in 1990. And here's prices for 1910, which is the last full year of 2010. So prices are 50% higher based on this sort of aggregate index that they have. I'm not sure exactly why their index starts in 1990, but the World Bank has an index that starts in 1960. And there's the FAO index, and there's the World Bank index. And if you look at other prices, there's nothing funny about the World Bank index. You can see it's almost identical here for the period where they overlap. If you look at particular prices, prices of food today are about the same as they were in the 1960s, and actually a little bit lower than, say, the average from 1960 to 1980. There was a big decline from 1980 to the 90s. It continued till about 2000. Prices in 2000 were less than half of what they were in this period here. This is actually indexed to 1990, not 1980. But they've been going up lately for a variety of reasons. Now, I said when I gave my PA presidential address that maybe someone would want to offer to bet me that prices are going to go up in the future, and I'll bet they go down in the future. And so Stan Becker, distinguished demographer here at the Johns Hopkins Bloomberg School of Public Policy, mentioned to me, met me in the hall afterwards and said, I think I'm going to take you up on that bet, and called me a couple of weeks ago and said, I'm serious, I want to do it. So we are today announcing a bet. Oh, I should have shown these are non-energy commodities, which look very similar. Okay, so here's the bet. Oops. Going to go back. Previous. There we go. There we go. Okay. So we have decided, now given the volatility in these things, and given that we're at sort of record highs, although as I said, that's kind of not as true as it sometimes said, we didn't just want to say prices from now till the going down in the future. Well, I would have been happy with that, but Stan said we should maybe smooth a little bit. So we're taking the average price from 2011 to from 2001 to 2010. We're going to compare it to the average price from 2011 to 2020 for these 5 food items in the FAO's index. And this is what they look like. You can see that they haven't all gone up the same amount, but mostly they've been going up. So basically the bet is for over this period here, we're going to average, we have averaged, and I'm betting they're going to be lower. So if they're 10% lower, then, and we're going to do $1,000, the same as Simon and Ehrlich did, then Stan owes me $100. If they go up 30%, then I owe Stan $300, and we'll contribute it to some appropriate organization given our somewhat different persuasions. So that's the story. So that's why I think the 7 billionth child is going to have a much better life than the 3rd, 4th, 5th, or 6th billionth child, and that we shouldn't be scared on Halloween, but we should be happy. Okay, thank you.
Thank you very much. Didn't I say you left the best for the last? Provoking thought, and but I think we'll spend the last few minutes looking at questions. We would alternate questions between the auditorium and our Twitter feeds. We have 2 questions so far on Twitter. And so we'll first of all start with the auditorium, just to be fair. We have microphones that we should use, and so, because this is all being webcasted. Because I run UNFPA, I'm looking for a woman to ask a question. Yes.
Thank you so much. For me, it seems that there are 2 double challenges that we are facing. That one is the increasing aging population in especially developed country, and they concern that low fertility rate because to sustain the increasing portion of aging population. But on the other hand, in developing country, we concern the increasing population because of the food crisis. So how do you think about these 2 challenges at the same time, and how can we solve this problem? Thank you.
What I would suggest is that we'll take 2 or 3 questions and then we'll run them. To be fair to you, you are the first to raise your hand.
Thank you very much. My name is Mehtab Karim. I'm a demographer nowadays at the School of Public Policy at George Mason University. Excellent presentations, but I have a question from all the panelists. And that includes, of course, a very important factor in projection in future, especially the way the population has been growing, that uncertainty of deaths, which could occur because of the way the world is going. Especially I come from the region. There are 3 major nuclear powers there, and anything could happen, and they have about 20% of the world's population. Have you ever looked at that scenario? Of course, that's going to be very important because in the 1970s, nobody could have predicted that there would be AIDS in Africa. And what if influenza situation comes anywhere in the world like it happened in 1919? So where the world population going to be? Thank you.
Thank you very much. We'll take a Twitter feed.
On the Twitter feed, a couple of people asked Brian if he's heard anything from policy people about the policy implications of what he said. One person said that it would seem like a cost-effective way to reduce emissions to have less population growth. Are you hearing anything from policymakers about it?
Okay, so shall we take the first 3 questions? Who would, Hannah, do you want to take the first question?
Yes, the first 2. So the lady compared aging populations with a food crisis because of growing populations and what is more important. I would say that the most important thing at this moment is the food crisis because it's immediate. You need to feed people immediately. You don't want to wait. We know that the aging problem, if it is a problem, in fact it is, we think of it not as a problem but as a proof of the success that the world has had in increasing longevity and reducing fertility. And every population of the world, you saw my graphs, every country of the world has had some decline of fertility, therefore every population is aging. There are different stages of the aging process, but everyone is aging. Everyone can expect, if people don't die earlier than we expect, to have more people that are older. And the good news is that most of these people that are getting older, they're getting older by being healthier. So it's a question of having societies change in the way they view old age and giving older persons more opportunities to keep on being active contributors to society. And the big problem is not aging per se, but the question of how some societies have organized themselves to make the aged live out of the savings they have or out of the transfer of resources from the younger generations. And certainly that thing probably has to change, but it's a political change and a societal change that is going to happen and is happening slowly. The second question about the mortality crisis. As you say, we tend to always be optimistic because we cannot predict exactly where the next crisis is going to happen. With AIDS, we certainly had not predicted that AIDS was even going to appear, but once it appeared, we have become pretty good at modeling the impact of HIV/AIDS. We're still optimistic because thanks to the work that our colleagues in UNAIDS and in the governments have done, in fact, the survivorship of the people affected by AIDS has been going up. And the epidemic has not actually exploded as some people expected. So AIDS has made a dent in population growth, especially in the poorer countries, but the dent is very small. And even tragedies like what happened in Japan recently and all that, you'd have a small blip in the mortality, but given the huge populations that we're having now, lots of deaths that you hear in the newspaper, they really don't account for a big change in life expectancy in these countries. So I've been asking myself, and in fact we're going to have a meeting on crisis mortality in a month's time in the population division, exactly what would it take in terms of mortality to really reduce population growth? And I'm afraid the answer is you would have to go back to the times, the good old times in which kids died at horrendous numbers when they were very young. That's the way mortality could really reduce population growth. And we certainly don't think that's in the cards, and we don't think that that is wanted. So no way that mortality is going to have a huge effect. And unless the world destroys itself, and maybe with climate change we are certainly trying to do it, I think that the future of our population has a lot of chance, as David Lamb said, to be better than it is today. But we do have to take some measures so that it is easier to get to that better life rather than more difficult.
I just have some comments on the first question about aging versus food crisis. I agree with Anya. If I was put in charge of one of these problems, I would pick aging, because I think that one we might know how to deal with. The food, gives me an opportunity to say I wouldn't want to have given the impression that I'm very cavalier about the ability to feed the planet. I think we've got evidence that we can do it, but it was a lot of work. The Green Revolution technologies that came in the 60s and in some sense kind of saved India right at the last second. It is not a big exaggeration. People had been working on for decades and did tons of research and lots of investment in it. And so I don't think these things are easy by any means. I think the food one's actually quite challenging. I think we can do it as we did in the past. The problems of aging, I think, are policy changes need to be made. Things need to be done, but I lose a lot. I don't lose a lot of sleep over any of them, as you can see, but I would lose more sleep over food than over aging.
So on the question related to policy and whether this kind of work has gotten any reaction on the policy side, I'm not that frequently or that directly involved in such policy discussions. A little bit here and there, and I would say yes, to some degree in a couple ways. One is that I think primarily NGOs in the field of reproductive health and family planning services have been interested to some degree because sometimes the argument is that an additional argument for those services is made that these policies have many, many, many direct benefits, but there may be an additional indirect benefit for the environment. And this kind of work, supports that general claim. It's not central, though, because by far and away the benefits of reproductive health and family planning don't have anything to do with the environment or climate, and that's not going to change. The second one is that in the climate policy world, I think this is more, I don't think really population per se has really entered any policy discussions, but it's one piece of, I think, a growing realization that development pathways in general are quite important to how well we're going to be able to deal with the climate change issue, whether by reducing emissions or by adapting to the climate changes we get, or most likely both. Often it can be kind of an emissions-oriented policy discussion that gets focused very much on technological solutions. And I think, in the end, on the emission side, those are critical. But there's a growing realization that if we're in a world that continues to do well along the lines that David outlined for the next 50 years, it's going to be a lot easier to cope with climate change than if we're in a world that things don't turn out that well, and population's one part of that.
Thank you very much. Let me just do two cross-cutting things which have not been mentioned, which I believe are also very important. Nobody has talked about migration and international migration. Well, that's an issue which we need to talk about, because it's also about moving populations. The other point which we need to talk about is aging populations also have the challenge of productivity. You are going to have a critical mass of young people to maintain a productive base. How do we address that issue? And finally, let me ask Brian, because now that I have the privilege of this, where do you see the issue of people in the conversation around Rio +20 and climate change? I think it's important that we talk about that, because I also believe that the climate change people and the environment people see this conversation without actually addressing the role of people in making those changes happen. Before you answer, I'll take 2 or 3 questions and then I'll revert. Yes, madam.
A lot of these comments, and they've been very interesting, but they're doing a lot of averaging. And when we average, I always picture the man that's supposed to be so comfortable because he's got one of his feet on a block of ice and the other in a boiling water. And isn't it nice that he's so comfortable because his temperature is just right? I wondered if we could add to migration, which you mentioned, and so on, distribution. And what do you see as the potential, since all of the positive prognostications assume a perfect distribution of the resources that do exist?
I'll just put a spin to that. Equity.
Yes.
Equity.
Distribution, of course, ultimately ought to be based on equity.
Yes.
I think the question is its departure from equity.
Yes. Okay. I'll take one more and then I'll revert to, yes, gentleman at the back.
I have a question for Dr. David Lamb regarding Paul Ehrlich's predictions. As we know, since he wrote the book, his predictions since the 1960s, the fertility rate has been declining all over the world. So had these rates, I wonder what you think, had these rates not declined, would have we been able to have the food, if these rates haven't declined since the 1980s, I think, like Nigeria for sub-Saharan Africa, then we wouldn't have like food productions which exceeded the population. So what do you think? I mean, if the population didn't decline, then I think Paul Ehrlich's predictions would have been fulfilled.
David, do you want to start?
Okay, a couple of things. I think you were talking about international migration mainly, and I think that's a very interesting question. I think we have a lot of it already. I think we're probably going to have more of it. I guess in some ways I think the more the better, and especially related to the equity issue. But that's a lot of politically complicated issues there. I think, of course, that it's also related to the population aging, in that Europe's and America's, for that matter, population aging problem may partly be solved by bringing in young people from Mexico and Africa and places like that. But very complicated politics, obviously. But I think migration is a very interesting issue. On the distribution equity issues, I think those are very important. One of the reasons I like to look at the poverty numbers is because they do really speak directly to what's happening at the bottom. And it is true when we look at data on inequality in, say, China and India, inequality seems to be going up as this huge economic expansion takes place. On the other hand, poverty is clearly going down, I think quite clearly. Many, that's a hard thing to measure, but I think almost everybody who looks at it agrees poverty is way down in China, way down in India, and down in many other countries as well. When you look at education, it's really the big improvements in education are really at the bottom, where you hardly see anybody anymore getting zero education in these countries. So I think it's a very important issue to look at. I do see sources of optimism there. Well, it's actually inequality is one of the main things I study, and there is a big, there are increases in inequality in many countries. I also want to mention global equity inequality, and I think in many ways, what we're seeing in China and India, Vietnam, Bangladesh, Philippines, many countries like this is big increases, big rising wages, in so many ways at the expense of people in Michigan and Ohio and places like that, textile mills, auto manufacturers, things like that. So I as an economist, kind of believer in free trade and so on, I often, when people say not to buy asparagus from Peru or somewhere, I always say, well, I like asparagus and I like Peru, and I think, I want to support the farmers in Peru. I realize it's kind of inefficient to do that, but I think, so this globalization has really, in many ways, at the expense of rich countries, but I think, that's okay, we're still rich. But these huge declines in poverty in developing countries have to be viewed as a good thing.
Okay, thank you, Dr. Ositimein, for asking about migration. It's my favorite subject. And just about 3 weeks ago, I was presenting a paper on migration and aging. Because every demographer you ask, unfortunately, is going to answer like David Lamb, yes, migration will help you prevent aging. But let's look at the numbers. The numbers of migrants internationally are really small. Most countries do not want to accept too many migrants. And when you put the data together, you find that once you accept a migrant and you allow them to stay, they age together with everyone else. So if you look at the population of migrants in the world, they tend to be older and the main receiving countries than the population itself. Now that's playing a trick, because when I do the numbers, and I have a presentation I can send you, you look at the migrants themselves, they're older than the population. But of course, the migrants had some children. When you also try to assess indirectly how much the young generation of the migrants helps rejuvenate the population, it varies very much, but mostly it doesn't. And while I was writing this paper, I discovered a fabulous jewel of a paper written by a demographer, mathematician, that used the model, the very powerful model of the stable population, and put migration in it. And essentially, the idea behind a very nice paper that you need to read is that imagine a stationary population. This is the population that occurs when you have one daughter per woman who survives and you maintain that forever. And it becomes the age distribution of the life table. Also, mortality remains constant. So he compares that type of process with, and in that process you have migration. The entry of people is at birth, at age 0. So then he compares that process where you have the entry of migrants at another age. And he shows that every population that gets to stationarity via migration is going to be older than the one that gets to stationarity via births, because the births enter at age 0 and the migrants enter at some other age. So that gives you a very good sense that in terms of a general rejuvenation of the population via migration, you're not going to get it if that's what you wanted, especially also in a world where everyone is aging. So what will really happen? What will happen is what we have seen happen all the time. If the economy needs workers in a certain place, they will get those workers, if they're paying well and if they're people that want to go and do the work. Sometimes even when the governments do not want the workers, if there's jobs and they're paying better than they're at home, you will get some workers. There's more than enough workers to go around in this time in the life of the planet. That did not happen, I submit to you, 500 years ago when people were relatively scarce. That's when we had to have slavery to move people around because they were not exactly wanting to go to the better jobs. But now that's not necessary. However, when you say migration is increasing, it will continue to increase, again, we have news for you. All the data that we're getting recently is migration to the important receiving countries has been declining very drastically. I met a Mexican that said the other day, we're shocked in Mexico that for the first time we have zero net migration with the US. And why is that happening? Because the economy has tanked. So it is the economy that moves this thing. It's not really aging. Aging will have an impact, and what we don't know is what impact. Countries that are very rich, they have to adapt, but they're already very rich. We have a very great doubt about what the Brazils, the Indias, the Chinas are going to do when they get to the stage of aging that the other countries are in. But we already have a sense that the people that are aging are adapting in their own way. They're saving much more than the Americans are doing. They're maintaining some idea of interfamily solidarity that will help them to maintain some kind of standard of living, not as great as their friends in the US or in Europe. And I think that that's what's going to happen, adaptation in different ways to different countries. Yes, migration will continue. Yes, it might be more because we have more people. But a total reconfiguration of countries because of migration, because of the imbalances in demography, I don't see it coming for more reasons than one. Lastly, about, what was it you asked? Another question. Someone asked a question about what would have happened if there had not been a fertility decline in the countries that declined. And I think that David has presented very persuasive information that ties more or less with what I say, that because of fertility decline in so many countries, things have not gotten worse. In fact, they have gotten better. But below that, the numbers he presents, the countries where things have gotten better, fertility has declined. You saw Sub-Saharan Africa. Sub-Saharan Africa is the one that has continued to have high population growth, and no matter what they're doing, they're not managing to get off the problems. You're talking about yes, globally we were meeting the goal of the reduction of poverty until before the crisis. I'm not sure now. But when you looked at the data, it was China that was moving the whole thing down. China alone reduced poverty, and the whole world reduced poverty. But that was not happening in many other countries. So I'm very happy about the question of distribution. I try to present to you some of the data by country. There's lots of variety. And within that variety, it is important to keep my three groups in mind. They are very different, and they're facing very different problems. And I would submit to you that partly it is because of the great differences in population dynamics they have had in the last 50 years.
Just one quick response on Dr. Osotomane's question on the role of people and as related to climate change and Rio +20. Actually, I think that's a good question, because historically in the climate change issue, certainly the research world and to some extent the larger debate, people have been kind of thinly represented there. I mean, initially the question was, is climate change happening? Is it a real scientific issue that we need to be concerned about? After that, it shifted really to mitigation or emissions reduction. How can we best reduce emissions to meet various goals? And only more recently has it turned to how can we cope with climate changes and adapt to them. And that question has much more to do with people and distributions of people and how the future socioeconomic development patterns will influence how difficult the climate change issue is to deal with. So I think that's a good sign for actually a more receptive kind of dialogue to connect the climate change issue to sustainable development overall.
I'll take one more question from the audience and one from Tweet.
People on Twitter would like to know where this 7 billionth birth is going to happen.
I can answer that right away. I don't think any one of us knows that. So I would, actually I'll take two. Gentleman in front and the gentleman at the back.
Thank you. Stan Becker. Could Brian or others address what some would call an ecological crisis facing us and population as a driver of that crisis? I'm thinking what wasn't mentioned is the water table that's declining in places like India and the American Southwest, the amazing deforestation of Brazil and Indonesia, the fish stocks that are down for many, many species, and the extinction, the massive extinction of other species on this planet. And it seems in this regard that sometimes we take a perspective that's a little too homocentric. And I would wish that you could address the other ecological crises and how population relates to those. Thank you.
Thank you. And the last question from the gentleman.
Thank you. Peter Okebukola, DRPH student, Health Policy and Management. My question is really looking at this from a policy standpoint. In terms of, we know that the countries with the highest fertility rates are also the countries that suffer from a burden of, communicable diseases, early deaths, high mortality rates as well. And so a lot of the fertility is born out of desire to avoid all the kids dying. So women will have more children because their kids will die off at some point. At the same time, we tell them reduce your fertility rates, but how do we develop policies that are relevant to that particular context? Also, talking about carbon CO2 emissions and all that. Yes, fertility rates are increasing in those countries, but they're contributing a disproportionately low amount of CO2. So how do we craft policies that mimic reality, if I can put it that way? So so that's my question for both Hani and Brian.
Anna, do you want to take that?
I'll answer the one about the mortality. You're correct that there's always been this idea that mortality has to decline and before fertility declines. It has not always happened, but the main point to make, and you saw it, the high fertility countries still have relatively higher mortality than everyone else, but the decline of mortality even in those countries has been enormous. I bet to you that they are. I have looked at the figures superficially, not with enough detail, but these countries have already reached lower levels of mortality than the levels of mortality that the countries that had a very rapid decline reached when they started declining. So we cannot longer continue to use the mortality as an excuse for we cannot do anything. Besides, we also know that these countries have about 0.25% of their married women who do not want to get pregnant immediately or want to stop childbearing altogether and are not using contraception. So the demand for contraception is there. It's not necessarily to stop childbearing, it is also to space births, but it's the services that need to get to them. And if even they space births, they will start reducing the fertility and changing the aspirations of people. We also know, thanks to studies paid by UNFPA and others, that increasing the intervals between births will also contribute to improve the survival of children. So it's a win-win situation where you have feedbacks that help to improve the well-being of women and children if you provide the services they need.
Brian?
Okay, so my task is to briefly answer those two questions, and starting with Stan. So I think it's a good question, and I think it just raises that, yeah, we're talking about a slice of some of the issues that we're facing now, and there's a pretty big slice left that we haven't talked about. It did occur to me in listening to David's talk that I would be interested over that period of time to look at some of these indicators over the last 50 years of species numbers, water scarcity, and of course carbon emissions. Now, we weren't really paying attention to that until the last couple of decades, but these are other problems that we're going to have to deal with. I do think on thinking about population as a driver, that while the relative role of population likely does differ between these different issues, maybe larger for water, not as large in climate and so on, that the idea that there are multiple things going on, that the efficiency with which we're able to irrigate crops, for example, or to grow them in the best places, can make a huge difference. And so population, I think, in the end, is going to be one factor among several that needs assessment to see where it's actually most important. On the question about mitigation or emissions reduction policies that take into account the facts of the current distribution of per capita emissions, I think some of those are already on the table and have been for quite a while. The basic international principle is that industrialized countries where per capita emissions are higher have to move first. I think clearly there are parts of the world where per capita emissions are so low that talking about emissions reduction policies in those areas, it's just not relevant. However, there's a middle group of countries, right? China, India, emerging economies, Brazil, where per capita emissions are still relatively low, but the way it works out is in climate, you can't have your cake and eat it too. So there's lots of people who want to advocate a very aggressive low target for limiting climate change to a low level in the future. Now, that can't be done if we go about mitigation policy by saying US and Europe and Japan go first, then we wait 20 years, and then maybe China and India join, and we wait another 20 or 30, and the rest of the world joins. The math doesn't add up. You can't get to those low targets that people want and have this sort of graduated participation. And I think that that's a difficult policy issue that brings these equity issues into concern. Leaving aside the very lowest emitting countries, that is something that the policy world is dealing with right now.
Thank you very much. I know that, Brian, you wouldn't have a right to reply here, but I would just say that wouldn't it be then proper, as we talk about policy, to engage with non-emitters or low emitters at this point in time, to actually look at a different development business model going forward so they don't become high emitters? Because I think that that's probably, for me, a more progressive way of doing it. Whilst we engage with the high emitters to come down, you must also talk to the low emitters that this is not the way to go, and try to keep them low so that we don't end up with, having the US and Japan and all that, Europe to come down. Then you suddenly find that the Chinas and indeed Sub-Saharan Africa begins to emit, in a manner in which they might not be able to respond appropriately. And Hania, would I be right to say that prosperity cross-sex demographic transition, would that be appropriate?
Appropriate, of course.
Yes, okay. So I would like to end by calling on the Dean to make a couple of statements, and then I will close. Thank you very much.
Well, thank you. And I'm sensitive to the fact that I'm standing between you and the reception outside. But I do want to say that the panel and the presentations exceeded my expectations. So I can't think of a better way to celebrate this perhaps mythical birth, but with the speakers that we had and the insights that you imparted. So I think I speak for everybody who's in the room and for everybody on Twitter that we really benefited a great deal from your talks this afternoon. So I want to thank you very much and ask Professor Churlin to come to the podium if that's okay.
Let me join in my thanks to the speakers and our moderator today, and just say, for those who are not in this auditorium but beyond it, thank you very much for listening and watching. And for those who are in the auditorium, please join us at a reception in the Wall of Wonder just out the door and to the left. Thank you.
Let me just close. I see everybody's trying to stand up, but I'm going to have the last word here. Let me thank Andy and everybody, Brian, Hania, and David, for what, for me, has also been education. And I'm sure it has been for you too, on this matter. What I'm going to share with you eventually, and I would send a video clip for you, to you, is a collage of babies born on the 31st of October around the world in our offices. And so we'll do a competition. Who would you choose as the 7th billion baby? Thank you very much.